Hi ladies and gentlemen, this is Mr. Green and this is another in my series of recordings for geometry. I appreciate you listening to them. Where should you all be? Well, we should be through Unit 4 working on Unit 5 material right at the moment. Right today what I'm going to be looking at is area. Well, area differs from perimeter because where perimeter is the distance around the outside, area is how much a space is taken up. Okay? Differences in types of questions that you're going to be asked. If you were asked how much paint would it take to paint a wall, well, that's an area. If you were asked how much bricks it would take to put on a wall, that would be area. If you were asked how much carpet it would take to cover your floor, that would be area. If you were asked how much space is taken up by the garden, that would be area. All of those are areas. Area is always captured in square units. Units squared. Because what are we doing? We're going to multiply the units here, the base, times the height. That's the way we do it for a rectangle. We multiply the base times the height. And you notice how we've got base times height. So that's units times units, or units squared. Okay? So let's look at a couple of examples of this. If I've got a 4 by 8 rectangle, what am I going to do? I'm going to multiply 4 times 8. That's going to be equal to 32. Since it's meters, it would be 32 meters squared. And that's the way that you would answer that question. Okay? So, one of the complications that they give you is that they complicate it by showing you areas that are overlapping. And like we did with the perimeter, I extend lines, I extend sides, and then it gives me quadrilaterals that I can calculate the area for. So the area of each one of those parts is equal to the area of the whole thing. Okay? So the sum of the parts is equal to the sum of the whole. So that's what we're going to be calling the area sum postulate. So if I were given some smaller areas, and this one was a 5 by 3, and this one was a 1, and this was 12, and this was a 4 by 4, I could just find the area of each one of these. It'd be 15, 12, and 16, and I could add those together, and I would get 43 units squared. Did I add that right? 5 and 6 is 11, and 2 is 13. Carry your 1, 43. Yes, 43 units squared. That's the way I would go about finding a combined area like that. Okay? So let's look at a triangle. How is a triangle different than a rectangle? Triangle and rectangles have very similar situations, but if I take a triangle and I duplicate it, actually draw the same triangle. I did a lousy job of it there. On top of the other one, what do we normally get? We can get a rectangle out of it that way. And that's the way the formula for the area of a triangle was conceived. We took the base times the height for a rectangle, but since a triangle is only half of a rectangle, we're going to use 1/2 the base times the height. And that is the area of a triangle formula. So if we are looking at triangles, they don't all have right angles like that, right? So what are we going to do differently than just using the height here? Well, when we look at a triangle, one of the things we can come up with is called the altitude. It's actually the height of that triangle. If you go from the vertex down to the base down here, and you make a 90-degree angle by doing it, when you do that, you have found the height or the altitude of the triangle. Okay? Now, not all triangles have something that you can draw on the inside of it. Sometimes you have to go outside of the triangle to get that. Okay? How do I know that would be the height of that particular triangle? because if I extended the side out a little bit here, I would get a 90-degree angle. And that would be how we would know that this is the height of this triangle. Okay? Sometimes it'll be inside the triangle, sometimes it'll be outside the triangle. In this situation, the altitude is right here, it's the height. This one, it's the height. And this one, vertex down to the end, down here, making a 90-degree angle, that would be the height. Notice how it makes a little H? See that little H there? Down the side, and it makes a little H, doesn't it? That's how you can find the height. You always got to make certain you get that little H. Okay? Okay, that's the way you're going to be using to find the heights of triangles. Now, when we look at just regular parallelograms, we go back to this base times height formula. And the way we got that was really quite interesting. If we look at a parallelogram, we know the sides are parallel, right? The opposite sides are parallel to each other. But did you notice that if I took that triangular portion that's right there, okay, come on, work with me here. If I took that triangular portion and move it to the other side of the parallelogram here, like that, now you can see, hey, I've almost got a rectangle in here, don't I? As a matter of fact, if I just look at this, like this, I do have a rectangle, don't I? Then this formula for the area of a rectangle will work for that because all I did was slide that triangle over. Okay? So we find the height of the parallelogram multiplied it times one of the bases. Okay? So for a trapezoid, that doesn't work for a trapezoid because we have two slanted sides. So what we do is we use the mid-segment of the trapezoid. You know, we did that mid-segment last time, last unit, where we found the point that was halfway between here, halfway between these two, and halfway between these two. And there, that point, connecting them, that's a mid-segment, and we figured out what that distance was. That's what we're using right here in this formula. That mid-segment distance times the height of the whole trapezoid. And that will give us the area of the trapezoid. So that's one way of using that. And we're going back to that mid-segment stuff. See how we're pulling that stuff in from previous units, right? So this is a matching game. What is the area of a triangle? Well, the area of the triangle is this formula right down here. Right there. 1/2 the base times height. What is the area of a trapezoid? Well, that's the one that's the longest one here, right? It's the one we're using the mid-segment formula times the height. So what is the formula for a rectangle? Well, that's the base times the height. We got that one. Oh, wait a second. Parallelogram. What's the formula for a parallelogram? It's the same thing as the... There, that one. That one. Same thing as the formula for a rectangle. So those are the formulas. Are you going to be tested over these formulas? Yes. Should you memorize those formulas? Yes. Should you have anything that writes them down? Yes. Write them down. Make certain you know those formulas because you will be using those formulas. Here's an example problem that you might want to look at. Here I've got two slanted sides, so it's a trapezoid. Okay? And they're wanting to find the area of this trapezoid. So what am I going to do? I'm going to add the 100 and the 140. Here, adding the 100 and the 140, taking half of that, it's going to give me 120. Multiplying that times 84, and I get this 10,080. And since we were talking about millimeters, that's 10,080 millimeters squared. That's what my area would be. Okay? 10,080 millimeters squared. Here's a parallelogram. Okay? And since there's no height in the parallelogram, they're showing you out here the height is 16, and they're showing you that one of the bases is 18. So I'm going to multiply the 16 times the 18 and get 288 meters squared, and that would be my area of this particular parallelogram. Now, I know a lot of you looked at this and you said, but there's a measurement of 22 meters in here. Shouldn't I use that? No, that 22 meters in there is just extra information. It is the slanted distance here, but that doesn't help us when we're calculating the area of a parallelogram. So, let's see what else we got here. I think that was the last problem I'm going to work for today. I appreciate you all being here. I do appreciate you all when you're sending me information. You're telling me that you're in geometry and what course you're in and what section you're in, because it does help me in finding your records quickly and getting you answers quickly. I appreciate it, and I want to let you all know I'm here for you. I'm here in Togas if you need me. I'm here in Class Connects. Feel free to contact me, and let's get your questions answered and get those grades up. Talk to you later.